Unlocking innovation through robotics education. Welcome to our channel, J Robotics. Today, we're diving into the world of innovation with a project aimed at making a significant impact, a smart stick designed to assist the visually impaired. This device leverages the power of Arduino, an ultrasonic sensor, a buzzer, an LED, and a few jumper wires to create a tool that enhances navigation and safety for the blind. Now let's walk through the step-by-step connection setup that brings this smart blind stick to life. To assemble the hardware for our smart blind stick, start by connecting the ultrasonic sensor. Attach the trig pin to digital pin 9 and the echo pin to digital pin 8 on the Arduino. Next, establish connections for feedback. Connect the active buzzer, buzzer 1, to digital pin 5, the passive buzzer, buzzer 2, to digital pin 7, and the vibration indicating LED, LED 1, to digital pin 13. These connections create the communication pathway between our sensors and actuators and the intelligent brain of the operation, the Arduino. Now, let's dive into the intricacies of this connection setup. Before we upload the code, ensure you've selected the correct board and port. Go to Tools in the Arduino IDE, choose your board, for example, Arduino Uno, and select the port your Arduino is connected to. Now, you can upload the provided code. Our smart blind stick utilizes ultrasonic sensors to detect obstacles and provides feedback through LEDs and buzzers. The ultrasonic sensor emits sound waves, calculating distances by measuring the time for the waves to bounce back from obstacles. As distances decrease, feedback intensifies. Within 40 cm, the LED lights up for visual cue. At 20 cm, the LED stays lit and the active buzzer alerts the user. When the distance is 10 cm, both the LED and active buzzer stay active, and the passive buzzer adds a layer to the alert system. This ensures escalating feedback for the user's awareness.